Okay students, let's start now the next numerical. Here we are given calculate the volume of a dry gas at STP which occupies 28 centimeter cube at 14 degrees Celsius and 750 mm of Hg pressure when saturated with water vapor. So that means what? You need to eliminate the vapor pressure. So P total is equals to pressure of dry gas plus vapor pressure. So here P total is given 750, pressure of dry gas we have to determine. Vapor pressure is given 12 mm of Hg, that means here it will be 12. So pressure of the dry gas is equal to 738 mm Hg. Alright, now they are asking us, so P1 is equal to 738 mm Hg, V1 is equals to 28 centimeter cube and T1 is equals to 14 degrees Celsius, that is equals to 287 Kelvin. Okay, and they are asking it at STP. So at STP, P2 is equals to 760 mm Hg, V2 will be question mark and T2 will be 273 Kelvin. So now apply combined gas law. When you apply combined gas law, P1 V1 upon T1 is equal to P2 V2 upon T2. What you do this? 738 into 28 divided by 287, that is equal to 760 divided by 273 into V2. Okay, now see, if you check carefully, every time when it is at STP you have to find the volume. So now what we will do, we will make this ratio as constant. Now how we will make this ratio as constant? See, I'll teach you. So here if you see, then 738 into 28 divided by 287 multiply by 273 divided by 760, that is equals to V2. Okay, now this ratio 273 divided by 360 is 0.36. okay, you make this as 0.36. now what you have to do, you have to simply just do the calculation with respect to this number. Okay, now let's do this. 7 4s are 7 41s are and this 80. okay, so now this V2 is equal to 18 multiplied by 4 multiplied by 0.36. so your complicated calculation, no, it will get reduced. Now the answer will come very simple. 18 into 4 72 into 0.36, so that will come out to be equal to something around 25.9. okay, so answer is 25.9 centimeter. Now let's go ahead with the next numerical. Here it is clearly written, LPG cylinder can withstand a pressure of 14.9 atmosphere. So this is the pressure which it can hold. Okay, now the pressure gauge of the cylinder indicates 12 atmospheric pressure. So P1 is equals to 12 atm and temperature is 27 degrees Celsius. So this is 300 Kelvin. Now what happens, that due to sudden fire in the building, the temperature increases. Now they are asking at what temperature cylinder will explode. Cylinder will explode when this pressure will be equal to 14.9 atm. okay, so they are asking us at what temperature this pressure will be attained. So now T2 is the question mark. So now given single cylinder, so volume is constant. So volume is constant. When they are talking about single cylinder, volume remains constant. So when you apply combined gas law, but volume is constant, combined gas law with constant volume, I will have P1 upon T1 is equal to P2 upon T2. So that implies 12 upon 300, that is equal to 14.9 upon T2. So T2 is equal to 14.9 into 300 divided by 12. So 3 4s and 100 by 4 is 25. So this is 14.9 into 25, so that will come out to be 372.5 Kelvin. So at when the temperature reaches to 372.5 Kelvin, this cylinder will explode. Okay.